So how we are going to do this is, okay. So how we are going to do this is, we'll go through few slides. We'll go through some of the basics, and then we'll do a hands-on workshop in here, where there's a Google collab notebook that all of you can clone and start, running the command along with me, and also understand what we are doing as we go down this path.
सब्जी
So
कौन सी?
आलू की दही के छौंका लगा दी।
हाँ, दही है तो चावल भेज दे देना।
Aryan, can you turn off your mic?
Oh, sorry.
thank you. So the topic for today is intro to machine learning, and we will build a spam email detector doing this. So a little bit about me. I'm a software engineer at Meta. I have like approximately 6 years of experience, and I work at the intersection of software engineering and artificial intelligence. And it's wherein you have artificial intelligence, you have a ML model or a deep learning model, and you want to like integrate it into your scalable system. How you're going to do that, and that's where I am like trying to like help companies build solutions, so those AI solutions can actually like work in the real world scenarios. One fun fact about me is that I'm very particular about formatting. So I like things to be like, with good bullet points, colored, so on and so forth. And I get very annoyed when even a single thing is like, somewhere off, and and my brain just constantly keeps like thinking about that. So I just like at least documents and presentations to be like pretty right. So yeah, I think that's about me. This is what we're gonna cover today. We'll start with what is machine learning. We also want to like understand how machine learning is different from AI and TL and NLP and everything that you have been doing. And and this is what forms like the basis for LLMs and everything. So once you like start going deeper into this, your next course of action is learning LLMs. I also want to like introduce you to what an end-to-end machine learning pipeline looks like, and what are the different steps that are like involved in here when you actually want to like build a machine learning pipeline, when you want to like build a model and then just deploy it somewhere out there. And then we are going to like do the workshop, and then I'll also talk about what's next, because we don't end here. There's like so much to learn in this particular thing. And finally, we're going to do like a short Q&A. So, if there are like any questions, I'm making sure that those are addressed as well. So let's get started. What is machine learning? So machine learning is a way when you teach computers to learn from data. So what happens is like you have a set of data, and you have its corresponding result values as well. So for example, you're like looking at things, let's say, so you're like, how are you going to like do some sort of classification? So for example, how do I know that this is a laptop, or how do I know that this is like a case, uh, so on and so forth. So what happens is like, how we do is like, this is a laptop, right? So what you're going to do is you're like take a picture of this and map it to a value called laptop. Then you take a picture of the case, map it to the value, and give it a target value, which is called, where you'll call it case or whatever you want to do, and you'll feed this sort of data to the machine learning. So when you feed this sort of data to machine learning, the machine learning is going to learn the different patterns which are right out of this. And from these patterns, once you like give some sort of like test objects, for example, if I were to show a mouse, will the machine learning be able to predict that? Maybe, maybe not. That depends on what your data set has. That's how machine learning algorithms work. You give them some data, you give them some target values, and they do some predictions on that. Some real world examples that we have here is like spam detection that we are going to like do today in our workshop. Like, given an email, how much do you know if it's in spam or it's not spam? How does, and you cannot like sit around doing this like on a daily basis, but your machine is going to do this while you tackle like more important tasks around on your Gmail. So spam detection is like one of the examples for that. The second one being Netflix recommendations. I think we all use Netflix and we all know that there's like a recommendation section down there that tells us like what we like. How is that built? That's built on your interests, and that is like feed it to the machine learning algorithm. They use a deeper they use like a more advanced version. They're going to deep learning for that. But yeah, that's how they suggest what's next to watch. And then you have voice assistant. They have Siri, Alexa. They are able to like recognize your commands. How do they do that? So that's where this is what all ML is. And as like we are in 2024, we are like surrounded with more and more AI, machine learning, and deep learning solutions than we were like back in like 2019 or something. So what we do here is like rather than hard coding the rules, we actually want the computer to learn from these examples, learn the patterns, and then give us the output. So there's AI, there's ML, there's deep learning, there's NLP. How is like all of this? Where does this fit and what it looks like? So AI is like the bigger set of this. Like AI is the final like subset, final set. But then the ML is another subset of it. And then within ML comes deep learning, and then NLP. NLP is like natural language processing. It becomes a combination of ML where you use, ML and deep learning. So how is like each of these different? Let's start with an example, I think here. So for example, AI. I think you must have heard that there's like a bot that beats someone in a chess game. That's where AI comes into play. Tries to learn games. You're like trying to chat with someone and you're getting like some response from them. I think that is also like a chatbot being built. That is also an AI. When you talk about machine learning, it learns from the examples like we spoke about. So, for example, if you want to do a spam detection, if you want to do classification, if you want your machine to identify some object, that's when ML is going to come into picture. But deep learning, this is where, it tries to mimic like very slowly to like a human behavior because you have something called like neural networks, which our brains do. And that's how like deep learning will try to like, do a deep learning would try to do like more, let's say, rigorous classification. So, for example, you can use like spam to do ML, but you can do like spam classification using ML. But if you want to do Netflix recommendations, that's what deep learning is because you're like trying to learn a human brain pattern here. And when it comes to NLP, it's more about like reading through chat messages. Or you want to like learn out of like your system. You have like a lot of logs in your system, and you want to learn something from there. That's when you'll start using NLP because that's like literally human language, and that gets translated to the machine, and then it helps us like understand, gain the insights out of it. So now we learn what distinguishes one from the other. We now start focusing on the machine learning pipeline here, like what it looks like, what are the different steps which are like involved in here, and uh, what is like, what we do in each of these steps. So to begin with, I think the first one is like you collect the data. Trust me, this is like the most important part of doing the machine learning. You just gather the examples which are out there. So for example, like you see this example in here where it's like you just get an email which says like free entry into a weekly like competition or something. And like you can look at these wordings and you can clearly say to yourself that this is spam. And then if somebody emails you saying that, hey, are we still on for dinner? That becomes an ham. A ham is like not spam here. And I want to like make sure that you get used to these terms like spam and ham, because that's what we are going to use in our workshop as well. So you try to like collect data, and the more better your data is, the more clean, the more less error prone your data is, you're going to have like better machine learning predictions out of it. Uh, while it looks very easy that somebody just builds the data set and you use it, there's like a very hard time when you have to like do this all by yourself. So let's say you want to like build some more complex solution in machine learning, you got to start collecting your own data. It's not going to be easy. That's why this is where you begin and you make sure that you have your data that's as good as possible. Once we have the data, we try to process it. So what happens is machine learning does not understand the language that we as humans do. So for example, we can very freely read that there's a free entry or hey, are you still on for dinner or so on and so forth. But machines do not understand any of these. They only talk in numbers. We all know about that. So that's when we do processing the data, where we actually modify, these uh, sentences such that machines can actually understand, and there are like different forms of way how we can like process the data. Once you do the processing, you train it. So you use different set of models in here, uh, and then the compute and the model is going to like learn from from the data that you have and from the target label that you are giving. When I say target label, it's basically saying what the machine wants to learn. So for example, whether it's want to learn spam, whether it's want to learn ham, that's going to become the target table here. That's where you start training the model. Once you train the model, you want to evaluate it. How do you evaluate it? So for example, you have like 200 uh, 200 rows which tell you that whether this is spam or ham. But you don't want to use only 200 rows right in here, 200 data points right in here, because you want to make sure that the model that you're like actually trying is valid, right? So it is able to like, so for example, I can like, if I give it a new, a new sort of like a sentence, then still it should be able to tell me whether it's a spam or a not spam. And how can I do that? So for that to happen, you take your data set, you split it into, maybe 70-30, 80-20, so on and so forth. And when you split that data, what you do is like you use the majority of the data to train your model. And then the remaining part of the data that you have that goes into like, uh, testing the model. So you're like seeing that part where you're like, okay, the machine has not seen this data, the model has not seen this data. Can it still predict what I'm interested in? Can it still give me the right sort of result? So that's when you evaluate the model in here. And the first one is like deploy the model. This is where the real world impact happens. So for example, once you know that your model is like really good, you go out and put it into, out in a scalable way to a system, and then folks start using it. So that's when, that's when like you see the machine learning magic happening, that it's doing everything by itself. Uh, while we're gonna cover the first four steps in here, the deploy model is not gonna like happen in this workshop. So yeah. I think we're pretty much like with the introduction and everything. I think we can like now start with building a spam detector in here. These are like the steps that we'd go through. We'd load the data set, we're going to clean it, we're going to convert it to numbers. So we also see what it looks like how, you know, how the numbers look like. We're going to like train the model. We're going to take one model, which is going to be a multinomial naive Bayes model. This is going to be a very basic model. And then we're going to like test the accuracy. We're going to make predictions, so on and so forth. So I'll share the Google Collab link in the Zoom right now. So you all can like work along and we all can like do this together. Any questions up until now? Is it like making sense?
Guys, you can turn off your mic and ask any doubts if you have, or you can even put it up in the chat. So yeah, please do that.
Yeah, I just shared the collab link. Um, Please let me know if you're like able to clone make a clone out of it. So because you only have like your access to it. So make a clone out of it and create like your own, name it like whatever you want to do. And then we can like start here with this workshop. I'll give everyone like a couple of minutes so they can like clone it. Let me know like if you have any questions. Meanwhile, I'm willing to address it. Also, please let me know once you're like done. I'm gonna like give you a couple of minutes, so you know.
Bhumi, someone has Aryan has asked the question in chat.
Yeah, it's very hard to know like in Zoom, like if you're asking on chat. So please let me know. How do
Yeah,
you know
so
how much?
if anyone asks, we'll just give you a heads up so you can again switch back and yeah.
Yeah, yeah,
No
okay,
worries. I'll quote the questions.
yeah.
Um,
So question is, how do you know how much data is needed to train the model? Okay, so this like highly depends. So there are like different sort of metrics that you can use, and these sort of metrics actually tell you like how your model is doing. So what happens is there's this term called overfitting in training the model. That means whatever data you use the model, uh, whatever training data you use for the model, the model is going to give you right answers for that. So there's this metric called accuracy where you like verify what the how accurate your model is. And for the training data, it gives you like 100%. But when you try to test it on like on the data which it has not seen, it will give you like a very low accuracy value, like 30%, 40%. That's when you know that your model has overfitted. That's when you put like a large number of like data, large number of data into your model. So that's when you know that this is when you have to stop. Now that's like where you know that this one you have to stop. But is there a way to know this sooner? Yes. You want to like make sure that you're giving your model all the different examples, but at the same time, letting it learn some of these patterns by itself. So for example, I don't want to take like millions of objects in the world which are there and put it into the put all of these objects to use to train the model. But I actually want to see that, if a laptop and an iPad can be similar, can my model like, predict it by itself? So that's when you know that what sort of data that you want to put in. And you want like the machine to like learn the classification of like laptop versus iPad by itself because it's like very similar and it's gonna like put it into an electronic section or something like that. So I think it's just about like what are the patterns you want your machine learning to learn. You don't want it to learn everything, but you want it to learn like good amount, like maybe 70%, 80% of your, what you're interested in. Does that answer your question? Mm, okay. I'm not hearing any response, so okay. Yes, and when you have to like update that knowledge, you train it again on your set of data. So this is like a cycle, the machine learning end-to-end pipeline, which I showed to you, more of a cycle, wherein while you are done with evaluating the model, a lot of times like train. So from the evaluate model, you go back to like collecting the data and training the pipeline. training the model. Could you explain more on what do you mean Copilot and other models research data from web? There's like a web crawler for that, so they can always like go to web crawler and give you answers. But I'm not sure how that Copilot thing goes into your
Like
question of like.
when we use Copilot, or there is one more AI called Augment AI. When I used it, there was if it did not know anything, like it was giving the code was giving error, so I gave it the code, and then it did a web search on the documentation. It is documentation, and then
Mhm.
it brought me the result that your code is deprecated. You need to use this. So how did it search for the code and train?
Oh, so for that, I think there are like web crawlers out there. I think as you like get deeper into CS and system designs, there are like web crawlers, which is similar to like how Google search gives you something. Like if you were to like search something on Google, what's gonna happen is like there's a web crawler, there's an API that like goes, you know, looks at all the documents which are available, returns all the relevant ones, and then from there, you're gonna see like a list of all the available, uh, you know, that's how you see like list of all the results for your web search. But the only difference with the Copilot and ChatGPT doing this is like they rank it further. So given this, all of these are the results. Which one is the most relevant to the question which was asked? And that's where they do further web crawling to identify whether, this is the result that they're looking, this is the result they're looking to give it back to you. So yeah, I think we should get started. Um, I want like folks to clone the notebook. I think we're already at 9:07, and I want to like give enough time to this so, you learn how to like import the data, so on and so forth. Can we like get started on that? Is everyone like able to clone the notebook? Okay. Okay, let's start. So when you do machine learning, I think we use Python a lot in here because it becomes like very easy. Python is like more of a scripting language, at least for me. So what it does, like it helps you like uh, help you import these machine learning modules that you have. And when you like import those machine learning modules, you want to like do some like rigorous math, computation. So that's why it becomes like very easy when you like try to do with Python. So that's what like we are trying to do in here. And what we so we start with like importing the libraries. I don't want to like so there's like there's one way of doing things in here, which is like you import all the libraries that you need first, and then you go out and start building each of those components. But I don't want to do that here. We will import the libraries as we start using them. This is so that you also learn like what are the important modules or libraries which are required to do which are required to like just run a small machine learning model. So let's start. So we have like something called NumPy, we have something called pandas. These are like some of the models which are used in here. And when you like run this command, it's gonna like start importing all of these modules that you're like interested in. Once you have that module, you want to like load the data set. What happens is like we are bringing all of the data set that we're interested in into our Python notebook. So this is where we have the data right now, but we're going to look at what it looks like eventually. So let's load the data set. And when you do something, so we are calling this data set DF. DF means the data frame. That's very, frequently used in like machine learning models or deep learning, whatever you want to do. But DF is like basically a data frame that gives you like a table. And with data frames, you can do like a lot of like, complex operations as well. So that's why it comes in picture in here. So now let's look at what the data set looks like. So it looks like we have like 5 columns in here. And then we have, so we're just looking at 5, but we're going to look at how much data we have up until now. So it's going to be like the next set of things. So you see, there's like, there's like this message, and then there's like a value for it. There's another message, and there's like a target value for it. So this is like what your data set looks like, where, where it is like that, okay, this is my message, and I'm giving the output as this is a spam or this is a ham. Similarly, you see free and free, something that I'm like, that is a spam. So I want to like, I want to make sure that this data goes into the model and it's able to like understand that. So this is what the data set looks like. We have like, I have like kept like 3 columns in here which have none values. But I think what actually I want to do in here is I also want to like make you learn how we clean the data and what we do. Those are like not relevant. So eventually we are gonna drop them out from our data. And how we do that, we're gonna like see that here as well. So now we look at the data. What are like some of the top 5 examples that we have, and then now we see how many rows and how many columns we have. So for example, here we have like 5,500 rows. That means we have 5,500 examples for our model to train. And then we have how many columns we have? We have 5 columns, as we like saw it in the very first thing. Please run along with me these these cells, so you can like also like get similar output in there, because we're gonna like um so now we are like gonna see how many duplicate values we have. Is it so do you want to like if you teach your machine the same set of same data again and again and again and again, that's all it's gonna learn, or that's all the patterns that's gonna learn. That's not something you want. But you have to make sure what your data is. Like, you always need to make sure that your data is clean. Your data is something that, so for example, when you're looking at data, I think you need to think of like how you want to like teach a small kid out there. So if there's a small kid and you want to like, make sure that they learn something out of it, you're not going to like give them the same set of examples again and again and again. You want to like make sure that they observe you in different scenarios. So that's how they're going to learn. Similarly, that's what with machine learning is. You want to make sure that your data is like not duplicated. It's not, it doesn't have null values, because if you give it null values, it's not going to learn anything out of it. So if we try to see, there are like 403 duplicate rows in here. Then other learning, and I just spoke about like the missing and null values. So how many missing and null values counted there? So here, so we care about V1 and V2, the V1 being the target label and V2 being our message that we want to use for the model to train. And I think for the remaining 3 columns, it's more or less null, because we don't care about it. I mean, it's nothing in there. It's just some data that somebody wrote there, and now we're just like using it, but we want to make sure that we are like refining it. And what are the names of the columns now? So this is like, there's like a V1, V2, unnamed columns. There's always an ability to rename these columns, and we are going to do that eventually in this workshop as well. So you're going to like, they're like just going to like rename these V1 and V2 to something more meaningful, because this data set belongs to someone else and you're using it. You want to make sure that, it's tailored according to you and you're able to understand what you're like trying to do. So this is like data set column. Then we check for like unique values for these variables. And I think we only care about spam and ham. So that's why you see that there are only 2 unique values in here in the data frame. You don't want it to be like anything third for now, right? All you care about is whether you want to like see whether your model is able to predict a spam or a ham. So I think for number of unique values for this one is 2. For this one, there's 5,100. It's like pretty close, which is really good, because we have like good amount of like, different patterns in here, as opposed to like just one pattern being repeated again and again. And then there's like number of unique values in the remaining 3 columns, which I don't think we care about. So yeah. Then I spoke about that we can rename these columns. This is what we are doing in the next cell, which is like we are going to rename the V1 with the category and V2 with message. When we say category, category is basically the target label, which is like a spam or a ham, and the message is going to be the contents of the message in here. And when we do in place equals true, what we're trying to do is we don't like create a new data frame out of it, but continue using the existing one. So what it looks like is, and then, like I said, the remaining three columns we don't care about. So how do you drop it? It's just using df.drop and then, putting the column names in there, doing in place. That means do it on the same data frame, and then you just drop them. And then when you create a binary, you want to like, so like I said before, right? Machines don't understand human language. So if you were to give spam and ham to machine, the machine is not going to give you is not going to be able to understand that spam and ham because it's your language, it's not the machine's language. So that's when you convert these values into some numerical values. So for example, here when for the spam, what we are doing is that if it is a spam, we will give 1, else we'll give it 0. So you are adding a new column to the data frame, and you're making sure that it's such that it's able to it's such that the machine is like able to comprehend and hear of what this is. So we do that, and then when we try to do df.head, this is what we get. So we get the category because we renamed the V1 to category. Then we get the message because we renamed the V2 to message. This is the new call. These are the renamed columns of the existing data frame that we previously saw. And then this is spam. This is a spam column where you're like, doing 0 and 1 and here based on like whether it's whatever the value of the target label is. And guess what? Spam is what we're gonna like send it across to the model as the target label. So, okay, we did, we did this. Now we cleaned up our data. We also like made it a little better, but there's still something that's left to do. Does anybody know what we are still missing in here? Anybody willing to like? You guys can just speak up. You don't need to like put it in the chat. You can just speak up and hear.
Bhumi, can I?
Yeah, go ahead.
Yeah, I guess category. We are like we have not changed them. Like the category values to 1 and 0. Maybe that's it.
We already changed the category values, right, to 0 and 1. What else is so ask yourself this question: if you give
So
this
yeah.
to your model, is it like gonna learn out of it? Because there's something that we are still missing in here. And what is that? That's something that I actually want to, because I've been repeating that over and over again. No? Nobody? Okay. So if you look at the message is still in human form. And if you give this out again to the model, it's not going to be able to learn it. So you want to make sure that the message is also converted such that, such that the machine is able to understand over there as well. So that's where the surprising part happens that, oh, can machines actually learn these languages? Which is like, can it read like the free entry into a weekly comp to win FA Cup and then be able to say whether it's a spam? The answer is yes. The machines can do that as long as you are able to represent this data in the right form. And there's like a lot of way to do representation of this data. There are like so many ways you can like pre-process this data so it becomes possible for the machine learning algorithm to understand that data, similar to how you understand. So to do that, that is what we call feature engineering. Feature engineering is basically taking that data, creating features out of it and giving it to the model, because the model is not going to learn everything by itself just by looking at the data same way as you look at. So you need to give features to it. And that's what we are going to do in the next step, that we're going to like convert these messages such that the machine or the model is able to like understand it. So what we use here is like a scikit-learn. Scikit-learn is like a very nice sort of like library available where you can do like machine learning very easily. You can pick a model of your choice. You can like take your data and like you can do some. The good part about like using scikit-learn is like you can experiment with all the different sorts of feature engineering available to you. And uh, I think that's like a really good way to like learn machine learning. What are the different set of features that come in, or what are the different sort of features which are like given to the model, and how it's like able to learn out of each of those. So here what we're trying to do is use something called counter vectorization. And what counter vectorization is it's gonna like take one message. So for example, okay, and I'm gonna like teach it with like a small example. So what's gonna happen is we're gonna like look at, so let's look at this one. So it will take this one particular message, you know, uh, so we have this, right? This one message. What the machine, when you do this counter vectorization, what's actually gonna happen is you're gonna get individual words like free, entry, and two. So what happens during this time is like there's one more processing, pre-processing that you can do. There are like some sort of words that you don't need and which are like very common. For example, you don't care about in here. You can just so that's another sort of pre-processing, and I'm gonna like give some next steps so you can like learn and do these sort of pre-processing as well. Continue working on this one. So there's like free, entry, two, you care about weekly, you don't care about because it's not contributing a lot to the sentence itself. And when you do like these sort of things, uh, and then what you're going to do is like, you're going to convert it in a bag of words. This is what a bag of words look like when you do concept factorization. That means how many times does free come up? How many times does entry come up? How many times does this, two come up or weekly come up? Is it like spelled correctly? So on and so forth. So this is what we do here. In this particular step, we are doing the count vectorization. We are taking the data, we are like converting it into a bag of words. We'll also see an example of that, what it looks like. So now we just did the counter vectorization, which is like the feature engineering. Let's look at what X actually looks like. Gonna do this. So you see, this is a compressed sparse row matrix. What so your columns are all the different words, and your rows are the number of examples that you have. So you have 8672 different sort of words here in this particular data, and then you have 5572, 5500 examples of rows. That's what we saw in the first when we looked at the data as well, that we have 5500 rows. But this is new, that we have 8672 rows now, which are like in this form. Uh, okay, so I think this explains like what vectorization or feature engineering looks like. Now, I think I previously like also highlighted on this one is that you have like a model, and and you have these like 200 data with you. You don't want to like train your models on the 200 data. You actually want to make sure that you're splitting that data so that you can like use majority of the part, train the data, train the model, and the remaining, can go to test. Test being that you're not making the so what happens when you train the model is you give both your X, which is in our case the message, and will also give the Y. The Y being the target label, whether it's spam or ham. But when you actually want to test, you don't give the Y, you only give the X. So you see what your model is like predicting at the same time. And then you compare it like with the true labels that you already have from your data set, and then you compute the accuracy of your model. So, uh, we're gonna like split the data in here. So when we like split the data, we are calling it X train. X being like, what is the main thing we want to train on. X test. This is like the test part that we are like keeping aside. The Y train, which is like the target label in here, that's gonna go to the training model, and the Y test, which is going to be something that we want to like keep it aside so we can like compute the accuracy of our model. And we're like splitting the data here, and you can see that test size is like 25.25, which is like keep 25% of the data for testing and use the 75 for training. So we split the data, and we have like now 4 sets, which is like the X train, Y train, X test, and Y test. Okay, and then now the main focus is doing the model. We just pick a model out of scikit-learn. I recommend that there are like different set of models out there which go from like simple decision trees to to I think something like I think some deep learning algorithms. There are like different sort of things which are available when you like go into ML. I recommend like you start from decision trees and go slowly increase like your uh ability to understand ML models. Here we are like using a very simple naive-based model. The model is already available by scikit-learn. Model is already like trained. It's like a pre-trained model. We just use it on our data set to do it. So this is like the multinomial naive-based model. And to that, we are giving the X train and Y train. When you say fit, what you mean is like make the model learn the patterns of what we have in X train such that it corresponds to, such that it's able to give the results of the Y, which is like the target label in here. Now, you have a trained model. What's your next step? Like test it, whether it's doing right or not. So we want to like let's do some prediction on top of the model. So you give the data, the model learns something, and we do some prediction. So let's do some prediction on, uh, on the X train. So for example, we already showed the data and we want to like see whether it was able to predict or not. For Y train, it should definitely be able to predict. So the accuracy for your Y train should be really high because it saw the data, as well as also saw the target label. So it should have a really high accuracy. But will it do good in your like testing phase? We'll see about it when we like try to test it against the test. So this is where we're doing Y train. We are like trying to predict on the training data, and this is the test. We're like trying to predict on the test data. So this is how we do the predictions, and then we're gonna like compute the accuracy in here. So for example, there's like something called accuracy score, which is also available on scikit-learn. It's very easy to compute the accuracy in here. So for example, all you have to give is like if you want to compare the accuracy for the train, you just call that particular function. You give the original, original values and what are the predicted values, and that's all. That's all is required to like compute the accuracy score for both train and test model. And if you were to run this, you would see that there's like a 99% accuracy on the train model, which should happen because the model saw the message as well as the target label. Whereas the accuracy score for the test data is 98%, which is good. But does this represent the entire universe? That's still something that we need to like see about. So this is what it looks like to do an end-to-end machine learning model. I think we started all the way from like the data. I think this is what I'm talking about. I think we sort of like all the different steps. Um, we went through all the different steps that we like spoke about in here in our machine learning pipeline, where we collected the data, we processed the data, then we went out to train it, and then we went out to evaluate it. We still need to like deploy it. That's like a very complex process. When you want to like deploy these machine learning algorithms, because you need to make sure that you're like scaling it well. Those are like good models, for people can rely on them, and it's not and we also need to make sure that it's not like moving an important message into like a spam message. 1 to 2% time, that's okay, but we don't want our model to keep doing that again and again. So this was like our, some sort of like hands-on on how we can like do, or how we can like train one small model in here. Any questions on the workshop up until now that we spoke about, like?
Guys, you can unmute and ask your doubts. So, Bhumi, I guess like none of them have doubts since you like explained it really well. So, yeah, the workshop was really insightful and really fun. I think Vedant is asking something in the chat box.
Okay, can you? Okay. Yes, you can use logistic regression. No, you cannot use logistic regression here, because with logistic regression, you want to like, what do you actually want to, so for example, if you want to like predict if the house prices are going to go, uh, how house prices are going to like go up, that's when and what that value is going to be, that's when you use logistic regression, because logistic regression is morely used when you want to like play around with like numbers. This is like a pure classification problem where you're like classifying a message, you're putting it into either of the bucket, which is like either it's going to be a spam or whether it's going to be a ham. So you cannot use logistic regression to do classifiers. You can use decision trees, or you can use this naive Bayes, and there are like a bunch of other complex algorithms as well to do classification. If you want to do numbers, that's when you go with logistic regression. Okay. So I think I'm almost like done. I'm done with everything, and I like make sure that there's like some takeaway for you from here. So
Bhumi, sorry, this Pranav has some doubt.
how to write lambda functions if there are more substitute other than spam and ham. Oh, so are you talking about if there are like multiple labels? I would prefer if you'd like take off your mic so we can have like a faster discussion.
Yeah, Bhumi, Pranav is saying yes, that's the question.
Okay. So in that case, what happens is like in that case, there's like a different set of logistic regression that's available. And what happens is like, let's say you have like a cat, dog, and let's say you have, give me, okay, a rabbit. And you want to like classify based on whether it's a cat, dog, or rabbit. What happens in terms of that is like, there's something called probability logistic regression that's get computed here. So once you like start teaching your model with all of these data, it's gonna give out probability out of these three. So for example, the probability you give it a cat, and the probability is like, and you have like data like cat, dog, and rabbit. The probability for cat is going to be high. Let's say somewhere around point anything about like 0.6. And when that happens, you're gonna like classify it into a cat. So that's how we like do a probability function to do the classification if you have like multiple labels in your data set. Hope that answers your question. So this is like the next set of things that you can like do. Like I said before, we just did like one sort of feature engineering, which was like the count vectorization, where we converted into like a bag of words. But there's a lot more that you can do. So you can do a TF, IDF. You can do like the probability logistic regression that I spoke about, where you can have like, anything between zero. You can also apply probability logistic regression, not logistic regression. So that's something that you can like also apply in here. You can, pick one of your project. One example that I've given is like, build sentiment analysis on movie reviews here. So, given the movie reviews, can you like read the reviews and identify whether it's like a positive review or a negative review, which is very similar to what we did here in Spam or Ham. And there's like a lot of image classification that you can do, like on TensorFlow, so that's something that you can like explore. And I'm like giving you like some resources in terms of like there's this Kaggle data set where you have like bunch of data sets available on whatever you want. So I think this is like something really interesting when you're like getting into learning machine learning. So this is like, see, as you can see, there's like a Bitcoin historical data, there's international football results. Do you want to like predict who's gonna win the next FIFA World Cup? Can you like use this data to do that? So on and so forth. So I think this is like a good resource to use. And then I think scikit is also equally good. You can, that's what we were like relying on all this workshop. So I think it's a good thing to like also learn about scikit. And these should be like your good steps to start learning machine learning and get introduced to all the different, models and featureization that is available. So yeah, I think this is pretty much it. Any questions? I'm willing to answer those.
Guys, do you have any more questions, or shall we like conclude the meeting? I think Bhoomi, they don't have any more questions, so I think we can conclude the meeting. Thank you so much. It's really been an insightful and it's been a fun workshop. So yeah, thank you for that.
Yep, I'm glad I could help. I'm happy to like share these slides with you, so you can like share with the participants if they need it.
Yeah,
You
so
just
like you could
send
send
it
us,
to us.
you can
We'll
send it to us on mail and we'll provide it to the participants.
Yeah, sounds good. Okay.
Perfect. Okay.
Thank you.
Thank you.
Thank
Have a good
you.
day.
Good luck everyone for the hackathon.
Thank you, Bhumi.
Yep. Bye bye.